Okay, so what we've got to do with these is plot these points and try to identify what figure we have created. It's important to label these points as we do this so that we know which part of the figure we are talking about when we make certain statements. So, the slope of AB, we can just straight up count that. That is down 8 to the right 2. So negative 8 over 2, or negative 4 over 1. BC is going to be down 4 and to the right 10, or negative 2 over 5. It is going to be helpful to simplify these just because of some things that can pop up as we are working through these. And then CD, we want to start at D and go to C because that's from left to right, so that would be down 1, 2, 3, 4, 5, 6, 7, 8, and to the right 2. Or negative 4 over 1. And then DA, we start at A and go to D, we'll go down 4 and to the right 8. Or sorry, down 4 and to the right 10. So I'm going to highlight the simplified versions of these fractions. And it's going to be important to get in the habit of simplifying them because we can see right away that, actually let me highlight these differently. The two yellow ones and the two green ones are exactly the same. And so that means that those two pairs of lines are parallel. So we can make the statement that since their slopes are the same, those lines are parallel. That would mean that 4 over 1, AB is parallel to CD. So we'll mark that. AB is parallel to CD. And then BC is parallel to DA. So my left side and my right side are parallel, and my top side and my bottom side are parallel. Now we need to look at angles, and this is where the conversation about perpendicular comes in. And so we need to look if any of these sides are perpendicular to any of the other sides. And for that to happen, we would have to have slopes that are opposite reciprocals. And we do not, so none of these are going to be perpendicular to any of the others, because we do not have opposite reciprocals. Parallel sides, again, we do know that AB is parallel to CD because the slopes are the same. And BC and AD, are they parallel? Yes, they are. Their slopes are the same. And then side lengths, this is a place where we're going to cheat a little bit. And so we could use the distance formula or the Pythagorean theorem to find the side lengths of these figures. But what we're going to do instead is we are going to consider the triangle that rests up against each of these sides. And so, for instance, this triangle here is 4 by 10. So for BC, I'm going to make a triangle really quick that is 4 by 10. We don't know how long the hypotenuse is. And then for AB, we would have a triangle that is 2 by 8. We don't know how long that side is. CD would also be 2 by 8. And then DA would be 4 by 10. So what we do know is, without doing any math, this is a very important trick to understand. This triangle and this triangle are congruent. They're both 4 by 10. That means that their hypotenuses are the same length. this triangle and this triangle are also congruent, that means that their hypotenuses are the same length. So from that, we can say that AB is congruent to CD, and BC is congruent to DA. So these pairs of sides that are parallel are also congruent. Because we have two pairs of parallel sides and the opposite sides are congruent, this is a parallelogram. Okay, on to our next shape. We're going to have the point 1, 4, the point 5, 1, 1, negative 2, negative 3, 1. It looks like this figure has pairs of opposite sides that are parallel and congruent. We will see. So looking at the slope of AB, we would go down 3 to the right 4, negative 3/4. BC would be up 3 to the right 4, so positive 3/4. CD, negative 3/4. And DA, positive 3/4. If I look at these two slopes are parallel, and so are these two. So we know that we do have opposite pairs of parallel sides. If we look at the slopes, we do not see any that are opposite reciprocals, and so we have no perpendicular sides. We do have some that are opposite, so like negative 3/4 and 3/4 are opposite, but they are not reciprocal, so that means they are not perpendicular. And then opposite pairs of parallel sides, AB and CD, are parallel, and so are BC and AD. Then lastly, side lengths. We can look at the slopes to see these side lengths. It would be a side length of 3, 4 for each of these triangles, and I will just demonstrate that really quickly. This triangle would have a side length of 3 by 4. That means that these would all have hypotenuses that would be the same length. So the side lengths of the figure would all be the same. So, since those triangles are all congruent, the question mark would be the exact same number for each of them. And the question mark would be the piece that is the hypotenuse of this triangle, the hypotenuse of this triangle, the hypotenuse of this triangle, and the hypotenuse of this triangle. So since those hypotenuses would all be the same, that means that all of our sides are congruent. We also need to mark parallel, because we did have that AB is parallel to CD, and BC is parallel to AD. So with that, if you were to look at your sheet, we have opposite sides that are parallel, all sides are congruent, no right angles. This is a rhombus. Okay, and so next figure, we've got 0, 2, 3, negative 3, negative 2, negative 6, negative 5, negative 1. And so here we We're going to look at the slopes, and I forgot to label my points, darn it. There's A, B, C, D. And so from A to B is going to be a change of 1, 2, 3, 4, 5, negative 5 over 3. BC is going to be 3 over 5. CD is negative 5 over 3. And then 3 over 5. So this is the first case where we do have a couple things going on. We have this side and this side are parallel. Slopes are the same. This side and this side are also parallel because the slopes are the same. And we can see that the yellow ones and the green ones are perpendicular. So we'll get to that in a little bit in our list. Actually, it's next in our list. AB, is it perpendicular to BC? Yes, it is, because those slopes are opposite reciprocals. So AB and BC, we do have a right angle there in the corner. BC and CD, opposite reciprocals, yes. So we have a right angle here. CD and DA, yes, and yes. So this figure has 4 right angles at the corners. We saw that, we'll talk about parallel now. AB and CD are parallel because the slopes are the same. BC and AD are parallel because the slopes are the same. So opposite sides are parallel. And then the last piece, side lengths, we're going to use our triangle trick. And I can just use my slopes for it because my slopes are simplified. So we would have for AB a 3 by 5 triangle. It's a terrible looking triangle, looks like a shoe. So again, AB there, the triangle that would sit on the edge of that figure would be 3 by 5. Same is going to be true for BC, CD, and DA. So since all of those triangles would be congruent, all of their hypotenuses would be congruent as well. The reason again that is significant is that this triangle has that hypotenuse, this triangle has that hypotenuse, this triangle has this hypotenuse, and this triangle has this hypotenuse. If all the hypotenuses are the same, are congruent, then that means that this figure has all sides that are congruent. Meaning that if we look at our list of properties, 4 right angles, opposite sides are parallel, all 4 sides are congruent, this figure is a square. Next, A is negative 3, 2. B is 5, negative 2. C is 3, negative 6. D is negative 5, negative 2. Let's connect these up. And we see slope for AB is going to be down 4 to the right 8. So negative 4 over 8. 4, negative 1/2. BC is going to be up 4 to the right 2. So 4 over 2. Or 2 over 1. CD is going to be down 4 to the right 8. And DA is going to be up 4 to the right 2, or 2 over 1. Now it is important to see that the reason why we want to simplify these is because, look, we have negative 1 over 2 there, and we have positive 2 over 1 here. So it's easy for us to see that those lines are perpendicular because their slopes are opposite reciprocals. If we had used negative 4 over 8 and 4 over 2, that it is not as obvious that those are opposite reciprocals of each other. So again, simplifying the fractions is going to be very helpful when we're talking about the slopes of these lines. So we do have opposite reciprocal slopes for AB and BC, BC and CD, CD and DA, and DA and AB. So 90-degree angles at the corners. And we need to talk about parallel sides, yes or no. Are AB and CD congruent? Yes. In terms of their slope. BC and AD, are they? Yes, they have the same slope. So these opposite sides are parallel. And then in terms of our triangles that come into contact with the sides, this triangle is going to be 2 by 4. So is this one. So AD and CB, AD here is 2 by 4. And BC is also 2 by 4. AB and CB is going to be a triangle that is 8 over 4. 8 long and 4 tall. And so is DC, 4 by 8. So both of these triangles are 4 by 8. So we can see from this that these two triangles would be having a congruent hypotenuse. And so would these two triangles have a congruent hypotenuse. So we can see that AB is congruent to CD. And we can see that BC is congruent to DA. So opposite sides are congruent for right angles. Opposite sides are parallel. Not all sides are the same length. This is a rectangle. Next, A is at 2, 6. B is 4, 3. C is 2, negative 7. And D is negative 4, 2. Okay. This is a bit of an odd-looking figure. So the slope for AB is down 3 to the right 2, so negative 3 over 2. BC is going to be positive 10 over 2, or 5 over 1. CD is going to be negative 9 over 6, or negative 3 over 2. And DA is going to be positive 4 over 6. Or 2/3. Now as we look at these slopes, we can see that negative 3 over 2 and negative 3 over 2 are congruent. That means that those two lines are parallel. And then we see we have a 5 over 1, which doesn't have any significance compared to anything else, but we do have a 2 over 3. And this 2 over 3 is an interesting one because it is an opposite reciprocal to both of these others. So that means that we have two pairs of perpendicular lines, which will make two right angles. Let's go ahead and list that out. AB perpendicular to BC, the answer is no. They do not have opposite reciprocal slopes. -3/2 is not an opposite reciprocal of 5/1. BC to CD, nope. They do not have opposite reciprocal slopes. CD to DA, yes. They do have opposite reciprocal slopes. And DA to AB, yes. They do have opposite reciprocal slopes. So where CD and DA come together is a right angle. Where DA and AB come together is a right angle. Next we look for parallel sides. Do we have any pairs of slopes that are the same? Yes, we do. AB is parallel to CD. BC and AD, the answer is no. The slopes are not the same. And then side lengths. AB, we would have a triangle that is 3/2. BC, we would have a triangle that is 10/2. CD, we would have a triangle that is 9/6. And then DA, we would have a triangle that is 4/6. And so we look at this and say, do we have any triangles that would be having the same length of a hypotenuse? And since their side lengths are all different, the answer is no. So there are no sides on this figure that are the same length. So let's mark what we do have. We do have a pair of parallel sides. We do have those two right angles. One pair of parallel sides with nothing else means that this shape is what we call a trapezoid. I guess you could technically call it a right trapezoid because it does have a right angle in it. In this case, two right angles, but that does not change the fact that it is just a trapezoid. Last one. We have 5, 1, 1, -5, -6, 0, and -2, 6. So, I need to label my figure. A, B, C, D. So slope of AB is going to be 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 6 over 4, or 3/2. BC down 1, 2, 3, 4, 5, 5. Down 5 to the right, 7. CD, up 1, 2, 3, 4, 5, to the right, 7. Up 6 to the right, 4. And then DA, down 5 to the right, 7. So we go through and look for anything that would be parallel. We can see that the 3/2 here and the 3/2 here are congruent, are the same, and the -5/7 there and the -5/7 there. There are no opposite reciprocals though, and it looks deceiving because it looks like those might be right angles. They are not. So what we've got is we've got to check out the angles. None of these are opposite reciprocals. Let me just check one more time to make sure that that's done correctly. 5, 7, 6, 2, 3, 6, 6, 8. So no opposite reciprocals, so no perpendicular, oops, no perpendicular pairs of lines. Parallel sides, yes, we do have AB is parallel to CB. And BC to DA is parallel also. Then lastly, we have to worry about side lengths. We can just use the slopes to determine the side lengths. So the slope for this one, before we simplified it, 4/6. BC, 5/7. CD, 6/4. DA, 5/7. So we do see that AB and BC will be the same length. Oh, sorry, AB and CD will be the same length because they will have a hypotenuse that is congruent. So AB is going to be congruent to CD. And then BC is going to be congruent to DA. Those hypotenuses would be equivalent. I don't care how long they are, I just need to know that they would be equivalent. So that's going to be it for that one. This does not have any right angles, and opposite sides are congruent, so this is just straight up a parallelogram. Oops. Okay, and that's it for this video.